Okay, before we start the simulation for today, I want to go over yesterday's work. I did have several students in my classes reach out and ask for questions on this form, and maybe some of the other science teachers did as well. I also did a couple Zooms with students to help them, so just make sure that you are reaching out and asking questions either by email or on Google Classroom, and I'm happy to do a call or a Zoom if we need to. So let me go over what your answer should have looked like from yesterday. So in the first column here, you just had to say, list the three phases of matter, the three common ones that we're talking about, solid, liquid, and gas. So, and then in the second, you're just giving examples. So examples of a solid would be like hair, computer, orange, bike. Could have anything there, rock, tree, dog, anything solid. And then in this third column, you're just giving characteristics, or properties would be another word for that. So solids have a definite shape and volume. The molecules are in a solid are tightly packed together. They don't move away from each other, and they have low kinetic energy. And then for liquids, my examples that I came up with were water, juice, soda, milkshake. And then so the common characteristics of liquids are they have a definite volume, but they always take the shape of their container. So depending on what you pour that liquid in, the shape will change. But the amount or the volume won't. The molecules can flow freely around each other. And then for gases, my examples are oxygen and carbon dioxide. I could also put helium. I could have nitrogen, hydrogen, water vapor. And gases, their characteristics or properties are they have no shape or volume. So they can just spread out or they can squish together depending on what kind of a container you put them in. The molecules move very fast in all directions and they have high kinetic energy. And then you had your analysis questions. So what's the biggest difference between states of matter at the molecular level? So here I wrote the molecules in a solid are tight, like tightly held together. They only vibrate, but they don't move apart from each other. In liquids, the molecules are more loosely connected and they flow around each other. And in gases, the molecules are not connected. They move around randomly, they move really fast, and the fast molecules always move faster as you add more heat. Then you were supposed to pick one phase change and explain how it happens in your own words. So I'm going to say for something to change from a solid to a liquid, you have to add energy. You could say you're going to heat it up until the molecules start moving away from each other. They start moving faster and faster, and it would melt and become a liquid. Okay, you could have picked a different one. You could have picked how something can freeze and become a solid, or how something can boil and become a gas. Just depends on how, whichever one you wanted to explain. And then the third analysis is explain what the video about iodine and dry ice were demonstrating. So they showed sublimation. That is when a solid turns into a gas when you add energy instead of it melting to become a liquid. And then the opposite of that is when you start with a gas and you cool it down and it turns straight into a solid. So it skips the liquid phase. That's why it's called dry ice, because it doesn't ever get to be a liquid. And that is called deposition. If you start with a gas and then you turn it straight into a solid, that's called deposition. That's the opposite of sublimation. And then the bonus was using the interactive periodic table and finding the melting point, like when it would turn into a liquid, and the boiling point of when it would turn into a solid. So I just happened to look up copper. And if you wanted to melt copper, you have to get it to 1064 degrees Celsius. So that's really hot. And then if you wanted to boil copper and get it to turn into a gas, you would have to get it to 2,948 degrees Celsius, like almost 3,000 degrees. So hope that helped. If you had trouble with it, you can go back and correct your document and just make sure you understand it before you move on. Okay, now we're going to get to today's demonstration.